Welcome to the video on mathematical modeling in coastal engineering by CWPRS Pune, serving the nation through research since 1916. This video will provide the information about the requirement, benefits and steps involved in mathematical modeling for coastal engineering. The coast is a dynamic zone where land and sea interact. The coastal zone provides opportunities to fulfill various demands through ports, thermal nuclear power plants, hotels and marinas, etc. Now, let's see the various phenomena occurring in coastal zone. Several oceanographic parameters like tides, wind and waves, sediments, and variations in salinity, temperature, and density. Together, they shape the hydro-morphodynamic behavior of the coast. There are a number of problems faced by the coastal areas. The open coast experience the effect of breaking waves, which causes the coastal erosion. Further, the tropical cyclonic storms results in strong winds, higher waves and storm surges leading to flood inundation, damage to coastal infrastructure. The strong currents or flows cause difficulties for berthing as well as maneuvering of ships, while the sedimentation in dredged areas or channels reduces the required depth, which hinders smooth vessel movement. Thus, it is inevitable to simulate these complex conditions mathematically beforehand to avoid the losses. Mathematical modeling allows researchers to test multiple design scenarios quickly, visualize coastal behavior, and gain confidence. For any model, it is necessary to decide the extent of domain area based on the phenomena to be simulated. Availability of field data, computational resources, and type of model to be utilized for the same. The mesh has to be generated based on the bottom contours and presence of geographical features in the region. Finer grids near channels, islands, or structures capture slopes and depths accurately. Such precision helps simulate flow patterns realistically to improve the model accuracy. Collected bathymetric data are merged into the model mesh after converting to a common datum. Measured chart and global datasets combine to form a seamless bottom profile, representing true seabed topography for accurate simulations. Once grid generation and bathymetry is completed, apply boundaries using measured or predicted tides, wave fields, river inflows, and sediment data. Wind fields vary in space and time across the domain. Proper boundary setup ensures realistic model performance. Model calibration adjusts parameters to match measured data, tidal levels, current speeds and directions. Wave climate and sediment observations from the model are compared with observed records to ascertain the nature, simile behavior of the model. The tidal hydrodynamic modeling provides information about the variation in water levels and current speed and directions over the domain, as well as flow patterns in complex areas. This will facilitate the researcher to evolve harbor layouts as well as finalization of reclamation shape and alignment of berths or jetties for smooth operation as well as minimal impact on existing flow. Further, the wave studies involve transformation of waves from deep water towards shore, using spectral wave models to determine the wave climate at the waterfront facilities, while the BW models are used for the further transformation of these waves up to the structure for better wave structure interactions and determine the wave tranquility inside the harbor areas. With coupling of tidal and wave models with the sediment model, the estimation of siltation can be carried out for cohesive and non-cohesive sediments. Sediment transport model provides guidance to stakeholders to plan the timely maintenance of the dredged area, anchorages and navigational channels for uninterrupted and safe vessel traffic. The dredged material generated due to dredging in navigational channels or dredged areas need to be disposed at suitable location in deep water. The dispersion studies help to identify locations for safe disposal of the material so that the material will not return towards the shore or dredged areas. The simulation of dumping is carried out for proposed rate and quantity of dumping at location identified based on availability of depth and current and wave patterns at that location. Further, winds, waves, surge and heavy precipitation during the tropical cyclonic storms cause destruction of structures and flood inundation in coastal areas. The simulation of past storms and application of statistical method provides the design conditions of storm surge and waves for the waterfront structures to avoid losses and inundation. The changes in shoreline seasonally. affects the waterfront facilities as well as tidal inlets due to either accretion or erosion. The shoreline change modeling predicts the probable changes in the shore either naturally or due to human intervention. The model is also useful to assess the effectiveness of the solution proposed to curb the shoreline changes as shown in the bottom right plots. CWPRS, India's premier research institute, has been at the forefront of coastal engineering for over 6 decades and has delivered numerous projects that continue to perform flawlessly. Its key contributions include finalizing the berth alignment and layout of 200 hectares of reclamation for the 4th container terminal at Jawaharlal Nehru Port. Other contribution includes assessment of the impact of over 500 piles for the 22-kilometer-long Atal-Seru Sea Bridge linking Mumbai and Navi Mumbai, while another landmark effort is the evolution of the diversion channel for the Ulvi River to ensure safe grade levels for the Navi Mumbai International Airport. Further, the institute has also evolved the breakwater layout and other studies for Kamarajar Port. A true feather in the cap is contribution to the upcoming Greenfield Major Port at Vedhavan, involving studies for harbour layout finalization, siltation assessment, identification of dumping sites, and evaluation of impacts on surrounding areas. These are only a few highlights of remarkable contributions by CWPRS. Thank you for watching the video. We hope this video has provided you insights about mathematical modeling in coastal engineering.